Recall that the standard form of a linear equation is ax plus by equals c. When both linear equations of a system are in standard form, the system can be solved using a method called elimination. The elimination strategy adds or subtracts the equations in the systems to eliminate a variable. That's where it gets its name. Now let's talk about what's happening with these numbers. They're called additive inverses. So negative 2 plus 2 is 0. 3 plus negative 3 is 0. Negative 5x plus 5x is 0. 9x plus negative 9x is 0. With an additive inverse, basically they cancel out or simplify to 0 if we add them together. We can use these to help us with elimination. We're always on the lookout for those additive inverses. How do we decide where they're going to come from, or rather, how do we decide which variable is going to eliminate or simplify to 0? So we can first look to see if one variable has the same or opposite coefficients. That's the one we want to eliminate, that variable, again, with the same or opposite coefficients. We need to be on the lookout for them in order to use this method. So if the variables have the same coefficient, you want to subtract the two equations to eliminate the variable. So here are same coefficients. Here's an example. It would be 3 and 3 for 3x and 3x. And that's why we would want to subtract, because 3x minus 3x is 0. It's almost like adding a negative. So if the variables have opposite coefficients, now having the negative in there already, you want to just add the two equations to eliminate the variable. So opposite coefficients like 3 and negative 3 and 3x and negative 3x would add to 0x and eliminate and go away. So let's see an example of this. It says solve the following system by elimination. So when I look at this system, 5x plus y equals 44, and negative 4x minus y equals negative 34, I'm trying to look for those opposites or same coefficients. So here in the equation above, the y variables have opposite coefficients. You have a positive one and a negative one. So choosing which variable to eliminate, that variable y would be the easiest to eliminate, because all we have to do is add the two equations together and it will go to 0. It cancels out, leaving us with x equals 10. Elimination, in one step, you've solved for one of your variables. We can then take that value of 10, and now it's very similar to substitution. We're going to substitute it into either equation. We're choosing 5x plus y equals 44 and putting the x in for the 10 in for x. And solve for y. If we simplify, we get y equals negative 6. So the solution is 10, negative 6. Plugging in x for 10 and y for negative 6 into both equations checks out as well, making that substitution and simplifying. So elimination brought us to our solution. It's another way, especially because we had opposite coefficients. We could just add the equations. Now let's look at another example. It says solve this following system by elimination. So again, 3x plus y equals 15 and negative 3x minus 3y equals negative 21. I'm looking for opposite coefficients or the same. So here in the above equations, the x terms have opposite coefficients, 3 and negative 3. They'll be the easiest to eliminate. When we add the two equations together, they go away. Then 1 minus 3 gives us negative 2y, and 15 plus negative 21 is negative 6, making our answer y equals 3. Now we can take the y equals 3 and make that substitution into either equation. They're choosing 3x plus y equals 15 and substituting in. If we solve, we subtract 3, divide by 3, you get x equals 4. So the solution to the system is 4, 3. It checks out when we substitute in x equals 4 and y equals 3 into both equations. 15 equals 15, negative 21 equals negative 21. So it checks out as our solution.